Good morning, good afternoon, or good evening. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, paper 5. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 says, fusion reactions are primary energy source of stars. Which row of the table gives the conditions necessary for fusion in stars? So we need to understand, for fusion in stars, density should be high. So density should be high. So we can say density should be high. Why density has to be high? If the density is higher, there will be more frequent collisions between nuclei. So we can say more frequent collisions between nuclei. So that's the reason we need high density. We also need high temperature. We need high temperature for fusion as well. Temperature should be high. So what is benefit of higher temperature? If temperature is higher, easily we can overcome repulsive forces. So we can simply say higher temperature is needed to overcome electrostatic repulsive forces. So I'll be writing simply to overcome repulsive forces, electrostatic repulsive forces. So the answer for this one has to be A, density should be high and temperature should be high. Second question says, astronomers use stellar parallax to determine the distance to nearby stars. Which of the following must be known to use stellar parallax? So for this one, you need to understand. So if you need to find the distance, we need this angle and we need this distance. And this is the distance from the center of the sun to the center of our planet. So this distance we need. So if you look at the given options, distance between Earth and the Sun. So R is the distance between Sun and the Earth. We need this distance. So the answer for this question should be A. Intensity of radiation received from the star, we don't need. So in this formula, you see we need angle, means we need this angle. We need the distance between Sun and our planet. So then we can find out value of D. Luminosity of the Sun, we don't need this one. Value of Hubble constant, no use of Hubble constant in this method. So this is also incorrect. So the answer for this one is A. Third question says, which of the following statements about nuclear binding energy is correct? Option A says binding energy per nucleon increases steadily as proton number increases. This is not true. So first of all, let's sketch binding energy per nucleon against mass number. So here we have binding energy per nucleon and on x-axis we have mass number. So first of all, binding energy per nucleon increases, it will reach a peak, after that it decreases. So curve look like this. So this is simply telling us always increases. That is not correct. So this option is incorrect. Binding energy per nucleon decreases as proton number increases. So initially it is increasing, then decreases. So this is telling us simply decreases. This is also incorrect. Binding energy per nucleon is approximately constant. No, it is not constant. It increases and decreases. So this is also incorrect. Binding energy increases to a maximum value. So this is the maximum value and this is iron 56. Iron 56. And then decrease as proton number increases. So after that it decreases. So the answer for this question has to be D. Question 4 says, a mass suspended from a spring is oscillating vertically. The oscillations are damped. Which of the following statements is correct? The damping force is always in the opposite direction to acceleration. So this statement is not true because acceleration and resultant force, they are always in same direction, but damping force has to be opposite to direction of motion, or you can say opposite to direction of velocity. So this statement is incorrect. The damping force is always in the opposite direction to the velocity. This statement is correct. The damping force is always in the same direction as the acceleration. This is incorrect. The damping force is always in the same direction as the velocity. This is also incorrect. Question 5 says a star is moving away from the earth. The wavelengths of spectral lines in the light received from the star are measured. These wavelengths are not the same as the wavelengths of the same lines measured from a source in the lab. Which of the following explains the difference in the wavelengths? So first thing you need to understand, in this case it is given to us the star is moving away. If the star is moving away, it means that it is redshifted. The light will be redshifted. Moving away simply means that redshifted. And redshifted simply means that lambda observed has to be greater than lambda emitted, means the wavelength of the light emitted from the source. The wavelength of light emitted from the source remains same. Star is moving away or star is approaching. Only the lambda observed changes. If the star is moving away, lambda observed will be greater. If the star is approaching, lambda observed will be lower, will be smaller. So this is the main concept you need to understand. As in Doppler effect we have studied, frequency of the sound produced by the source remain the same, but observed frequency change depending on relative motion of the observer and source, means the relative motion between observer and source. So the wavelength emitted remains same. So this is the key concept you need to understand. Now if you look at the given options, the star emits light with a shorter wavelength. No, this is incorrect. The star emits the light with a longer wavelength. No, because the lambda emitted remains the same. The light arrives at Earth with a shorter wavelength. No, longer because star is moving away. This is redshifted. The light arrives at the Earth with a longer wavelength. This one is correct. So this is incorrect. Question 6 says the moon is gradually moving away from the earth. The gravitational potential at the earth due to the moon. This sentence is very important one. So you have to be clear about this one. And the gravitational force between the earth and the moon are both changing. Which row of the table is correct? So first of all we can imagine this is our beautiful planet. So this is earth. And let's say the mass of this one is m naught, and this is our tiny and beautiful moon. Let's say the mass of this one is capital M. So we can say this one is moon. And let's say the distance between these two, the distance from center to center, this distance is r. So how the potential at the surface of our planet is changing when the moon is moving away. Moon is moving away, so simply we can write on here V due to moon, V due to moon at the surface of our planet. This will be equal to negative G capital M, means the mass of the moon, divided by R. So now in this case, if R is increasing, so this one is decreasing, not decreasing. Here we have negative sign. So its magnitude is decreasing. So it means this becomes less negative. So beautiful point. You need to be clear about this one. Most of the time students bit confused with these negative signs. So become less negative. And if it becomes less negative, it means value of V increases. So we can say increases. So the potential has to increase. So the answer for this question has to be B. Our answer has to be D. So this option is not possible. This option is also not possible. So the answer is B or D. Now we need to look at the force between them. So the F, gravitational force will be equal to G capital M, M naught, M sub naught. Capital M means the mass of Earth, mass of the moon, divided by R square. So if R increase, force between them will decrease. Increase, decrease. So this is correct. This is correct. This is correct, but this is incorrect. So the answer for this one has to be B. So B is the answer. Question 7 says a small satellite of mass 122 kgs is orbiting the Earth. The satellite is orbiting at a height above the surface of the Earth equal to the radius of the Earth here. So this is the satellite. And in this case, the distance from the center to this point, first of all, this is the height. So height is given to us, this is equal to radius. And this is also the radius of the Earth. So it means this total distance, this is equal to 2 times of r. At distance r, value of g should be equal to g capital M divided by r square. Now as the distance is double, so the new value of g, this will be equal to g capital M divided by 2r square. So we can say this is g capital M divided by 4r square. Or simply we can say this is g divided by 4. So what is new value of the weight? So we can say the weight. Weight simply will be equal to m times g prime. And m is given to us, this is 122 kgs and g is 9.81, means this value of g by 4. So this is divided by 4. This is 122 and we multiply with 2.45. So we're going to get about 300 newtons. So the answer for this question has to be B. Question 8 says, which row of the table gives the relative ionizing power and penetration of gamma radiation? Ionizing power. Gamma rays, they interact weakly with matter. Means the interaction with matter is very, very weak because they have no charge. So the ionizing power is low. But they have very high penetration power. As gamma rays, they can penetrate through lead. So we need thick wall of lead to stop, means to minimize the intensity of gamma radiation. So they have low ionizing power because they interact weakly with matter, interaction is very weak, and they have very high penetration power. So ionizing power is low, but penetration power is high. So low and high. So the answer is B. Question 9 says the HR diagram shows 4 areas P, Q, R and S where different types of stars are located. Which of the following is a possible path for stars initially in area P, mean in this area? As these stars, they are main sequence stars. So these are main sequence stars. So after that they become red giant. So we can say this region is representing red giant, and then finally, so they will go to this one, and then finally they will come to this. So this is the white dwarf. They will not come back to the main sequence again. So this area is representing white dwarf. So this is how you need to understand. So first of all, it is main sequence star. So this is main sequence star, then become red giant, and then it becomes white dwarf. So the answer for this one has to be P, S and Q. P, S and Q. So the answer for this one is B. Question 10 says a simple pendulum is displaced through a small angle then released. The frequency of oscillations is determined. The length of the pendulum is then doubled. By what factor will the frequency of oscillation be multiplied? So first of all, we need to understand the formula for frequency. F is equal to 1 over 2 pi G over L. So this is G over L. So we can say this frequency is F naught. Now what is value of F nu? So we can simply again rewrite this formula. So this is 1 over 2 pi G divided by 2 times L. So this is L. Now if we little bit rearrange, we can write down this is 1 over 2 pi. We can say this is G divided by L. So this is G divided by L. And we can take 1 over 2 outside. So this is the square root of 2. Now if you look at this, you can see this part is F. So this is representing F naught, and this will be multiplied by 1 over square root of 2. So the answer for this question has to be A. Question 11 says air is used to inflate a balloon. The inflated balloon has a volume of 1.77 times 10 to minus 3 cubic meters and contains 5.15 times 10 to 22 air molecules. The air inside the balloon exerts a pressure of this much. Calculate the average kinetic energy of the air molecules. Now we need to calculate average kinetic energy of air molecules. So we need to understand the average kinetic energy of air molecules. This is equal to 3 by 2 K times T, and temperature must be in kelvins. So but temperature is not given to us. K is a constant, so its value will be given to you in the data. So how we can find out the value of T? So from here we have value of V, and we have value of N number of molecules, and we have value of P. So now simply we can use ideal gas equation. PV is equal to NK times T. So from here we can find out value of T, that will be equal to PV divided by N times K. So value of P we have in this case, that is 1.15 times 10 to 5, and the value of V is given to us, that is 1.77 times 10 to minus 3, and value of N is also given, that is 5.15 times 10 to 22, and value of K is a constant. This is Planck's constant, and it is equal to 1.38 times 10 to 23. So value of this constant 10 to minus 23. Now if we solve this one, we will get 286 kelvins. So this is the value of T. Now simply we can plug in here. So value of K, Planck's constant, that is 1.38 times 10 to minus 23, and temperature is 286 kelvins. Temperature must be in kelvins, and if we solve this one, we will get 5.9 times 10 to minus 21 joules. So the final answer for this one is this. So this is the average kinetic energy of air molecule. Question 12. For question 12, a student has plotted data of P against volume. So this is what is given to you, and we need to assess the validity of student statement, and here is the statement of the student. The student stated that his graph demonstrated that the pressure exerted by the gas was inversely proportional to the volume occupied by the gas. So we need to assess the validity of this statement. So how we can assess? As in this case, P is inversely proportional to V. P is inversely proportional to V. So it means that PV should be equal to constant. So we can say it should be the product of PV. This one should be constant. Should be constant. So now simply we need to take some data points and we need to check this equation. And so we can take one point, let's say this 60. So we can take 60, we have value of P, and we can also read value of V from here. We can take 1 point, let's say this is 110, any point you can take actually. So this is 110, and we can draw here, so this is like this. Now these points we can assess. Now we can check these points. So here is 60, so value of P is 60, so I can say this is P1, so this is V1, and we can say this is P2, and this one is V2. So first of all, P1, V1. So value of P1 is 60 kilopascal, so we can say this is 60 times 10 to 3, and the volume is 0.011. If we multiply this one, we will get about 660 Pascal meter square. And now we can check P2, V2 as well. So here we have 110 kilopascals, and we need to multiply with the value of V from here. And the value of V is about halfway, means between 0.005 and 0.007. So it means this one is 0.006. And if we multiply this one, our answer again will be close to this value. Close to this value. And this is cubic meter, actually volume, not the area. So we are using volume, so this has to be cubic meter. So this has to be cubic meter. As in this case, P1 V1 is about equal to P2 V2. So the relationship is valid. So we can say relationship means P is inversely proportional to V is valid. So statement of student is also valid. So we can say student, or simply we can say, so the statement is valid. So this is how you need to answer. You can take another point as well. So this is how you will justify this statement is valid or not. Question 13 says alpha particles were fired at nitrogen atoms. The nuclear equation for this reaction is given to us. We need to calculate the minimum energy in mega electron volts required for the reaction to take place. So whenever any nuclear reaction takes place, mass must be conserved. Energy must be conserved. So for this nuclear reaction, it is also given to us the mass of oxygen. This is mass of oxygen, this is mass of proton, this is mass of nitrogen, and this is mass of helium. So how we can calculate energy? So first of all, we need to understand this reaction, what is happening here. So in this case, we have alpha particle. It has certain amount of kinetic energy, and we fire this one at nitrogen. So this one is nitrogen 14, and after this we have oxygen 17, and we have proton, or you can say hydrogen. And so how we can calculate the minimum energy? Question is very important one. You need to understand the concept, not using just formula. Minimum energy. So minimum energy means that the mass, how much energy has been converted into mass. So that much energy we must need. If we don't have enough energy to create the extra mass, it means that this reaction will not be possible. So the minimum energy is equal to the extra amount of mass produced. So let me write down here. So this is, you need to understand. So the E min must be equal to, or we can say must be equal to or greater than m extra, means extra mass produced. But better way to say, as I'm talking about, I will say this is minimum. So the energy must be greater than or equal to extra mass produced. So we are talking about the minimum. So the E minimum must be equal to m extra, at least equal to extra. So we will see how much extra mass is produced, and we will convert that mass into energy, and then we will be able to calculate minimum energy needed. So E min will be equal to delta m extra produced time c square. So how we can calculate delta m? So simply we need to find the difference. Mean this mass minus this mass, means mass of products minus mass of reactant. So we can get extra mass produced, then we can convert into energy, and then we can convert energy from joules into mega electron volt. So this is how you need to approach this problem. Now let me show you the solution so you can look at this one. So we can save some time and we can make this video a bit shorter. So what we have done here, simply we have plus mass of proton. So here we have mass of nitrogen. So this is mass of nitrogen. This is mass of oxygen, as I mentioned. This is mass of nitrogen, and this one is mass of helium. Simply we have subtracted, and this is the mass, extra mass, or we can say this is the mass difference. But you have to be very clear here. You see, if you look at up to 2 dB, these two numbers are the same, but if we go to 3 dB, this one is greater. So in the answer, in your calculation, you have to use at least 5 dB or 6 dB. So at least 6 dB I will suggest you have to use. Then you will be able to get this answer. So now we can convert this mass into energies by simply multiplying with c square. So this is what we have done. So this is the energy in joules. Now we need to convert energy into mega electron volts. So we need to understand 1 electron volt is equal to 1.6 times 10 to minus 19 joules, and 1 mega electron volt will be equal to 1.6 times 10 to minus 13 joules. So simply you can divide this one by this number and you will get answer in mega electron volts, or you can divide first of all by 1 electron volt, 1 joules per electron volt. You will get answer in electron volts, and then you can convert into mega electron volts. Part B says explain why the alpha particle must have an energy greater than the minimum energy for the reaction to take place. We have already discussed this point, so let me explain you a little bit more about this. So let's say this is our alpha particle and this one is nitrogen, and after this one we have oxygen. So this is oxygen 17 plus we have proton hydrogen. And so in this case, this one has initially kinetic energy, and some of its kinetic energy has been converted into extra mass to produce oxygen nucleus. So we can say extra mass. So that is equal to the minimum energy. Part of kinetic energy has been converted into mass, but initially as alpha particle has some kinetic energy and it has momentum, so the momentum after also has to be conserved. So this particle must be moving, so this one will have some kinetic energy and this particle also will have some kinetic energy. So the total kinetic energy of alpha particle, in this case we can say Ke total of alpha particle. So this is for alpha, so we can say E total of alpha has to be equal to delta M, means the extra mass produced, plus kinetic energy of oxygen 17 plus kinetic energy of alpha particle, means hydrogen, in this case hydrogen or proton you can say. So that's reason energy of alpha particle has been converted into extra mass, has been converted into kinetic energy of products. So its total energy must be greater than the minimum energy, because for any reaction to take place, momentum and energy must be conserved. So products must have momentum after reaction, so they will be moving. So it means energy of alpha particle should be equal to the kinetic energy of the products plus extra mass. I hope this makes sense to you. So this is how you can write down your answer. Question 14 says, at the beginning of 20th century, astronomers identified that a number of galaxies were moving away from the Earth. Far part A state how astronomers knew that galaxies were moving away from the Earth. So they observe light from the galaxies and they observe that the observed wavelength is greater than the lambda emitted, means the lambda in the lab, means the light is red shifted. So from redshift they concluded that galaxies are moving away. So simply you have to mention red shift. So how you can write down the answer? So this is how you can write down your answer. You can mention these points. This is important one. You have to say light from galaxies is red shifted. So this is the key word. It has to be in your answer, indicating galaxies are moving away. Part B says Hubble suggested that recessional velocity v of a galaxy was related to the distance d of the galaxy from the Earth by the expression v is equal to h naught d, where h naught is a constant. The graph shows some of Hubble's data. Assess the validity of Hubble's expression based on the data shown. Means you have to talk about data. The validity must be explained based on data, not something by yourself. You cannot say v is directly proportional to d, as h is constant, so it means this expression is valid. That is wrong. You have to explain based on data. This is how marks will be awarded. So first of all, if you look at the data, we can see this line is about a straight line. So simply we can say, as the line is a straight line passing through origin. So this is how you need to explain. Looking at the graph, passing through origin. So we can mention 1 point. So what this one is telling us? It is telling us that v is directly proportional to d, because we have v on y-axis, we have d on x-axis. So this is 1 point you can say. But there is a scatter. You see these data points, they are scattered. There is scattered, or you can say data points are scattered. So there is scatter. As there is a scatter, what this one is telling us? This is telling us uncertainty. So there is uncertainty. So these points you have to mention in your answer. So we can say there is a scatter of points. So there is uncertainty due to outliers. Means there is uncertainty because the points are scattered. So if you mention these points, you will get the marks. Now let me show you the answer, how you can write down a proper answer. So this is how you can write down a proper answer. So first point you have to say the data approximately follow a straight line through origin. So v is directly proportional to d. But there is scatter. So Hubble's law is supported but with uncertainty due to outliers. So this is how you need to answer, based on data. So question emphasize based on data shown. So you have to talk about data. Question 15 says a student is planning an experiment to investigate how the resistance of a thermistor changes with temperature. The student wants to use the temperature range 0 degrees Celsius to 100 degrees Celsius. Describe a method the student could use to determine values for resistance and temperature over this range. Over this range, very important. So you have to include this whole range. Means you have to talk about this whole range. You should include one precaution the student should take to ensure accurate experiments. You don't need to draw a circuit diagram. So how we can answer this question? So the first thing you need to understand is that we need to determine the resistance. So to determine resistance, we can use ohm meter directly, or you can use voltmeter and ammeter, but the simple way is to use voltmeter and ammeter. So we can draw a rough circuit. So we can say this is our battery and we can connect ammeter. You don't need this circuit diagram, but it's important for this experiment so you can organize your thoughts. So here we can place thermistor. So this one is thermistor, and we can connect this one. So here we can connect thermistor, and here we need to attach voltmeter. So we can read actually in this case the value of the PD across this thermistor with the help of voltmeter, and current we can find with the help of ammeter. We can also attach one safety resistor, so that is also possible. So safety resistor we can attach here, so current will not increase too high. So this is safety resistor. We can also attach small resistor here. So let's say resistance of this one is R. So first of all, you can say connect the circuit. So you will connect your circuit like this. The second, you have to start from 0 degrees Celsius. So you need a mixture of ice and water. So it will be at 0 degrees Celsius. So we will need mixture of ice and water at 0 degree Celsius. And when it is at 0 degrees Celsius, we will record what is value of I, what is value of V. So we can also draw small table here. So here we have what is value of I, what is value of V, and here we can find the resistance, that will be equal to V divided by I. So this small table is also helpful. And then we have to increase the temperature, means we will start heating that mixture. So temperature will start rising until it reaches 100 degrees Celsius. So also in that mixture of ice and water, we have to place thermometer. So here, let's say you have mixture of ice and water, you also need to place thermometer. So let's say this is placed on table. So this is how you need to organize your thoughts. So let's say this one is retort stand, and thermometer we attach with retort stand. It should not touch the walls. And we will take different readings of I and V at different values of temperature. And then finally we can sketch the graph. So we can say sketch the graph. So we can write on here graph between. So we can sketch graph between V and I. So here we can say this is V, this is I. And then the gradient. We can look at the gradient, we can see how the resistance is changing. And we also need to talk about safety precaution. So we have to stir the water before we take any reading. So temperature is uniform. And also we need to use small currents, not very high currents, to avoid overheating. So these are the points you need to include in your answer, and this is how you need to organize your thoughts. I hope this makes sense to you. And now let me show you the answer, how you need to write down answer for 6 marks. So these are the points I have written, so you can go through these points. So first of all, the first point, we have to connect thermistor in a circuit as we have done here. The second point, we have to place this one in the mixture of ice and water at 0 degrees Celsius, the second mark. And the third mark, we have to heat water to 100 degrees Celsius and record temperature with a thermometer. Fourth, measure V and I at different intervals. We can say after every 5 minutes, something like that. After 5 minutes, 2 minutes you can mention. So fifth point, stir water. So and ensure thermometer is close to thermistor. So if we place thermistor here, let's say it has to be close to the thermistor, close to thermistor. So let's say our thermistor is here, so it has to be close to thermometer. Small currents we have to use to avoid heating. So this is the precaution we have to write down. Small currents, or we can switch off between readings to prevent thermistor heating. So these are the points you have to write down in the answer. If you write down, you will get 6 marks. And today's video, I will stop here, but I will try to upload the solution of remaining questions by tomorrow or by today. If this video was helpful, please like and subscribe, because your support is very important. And also, if you are looking for extra resources, you can join Patreon. On Patreon, you will see a lot of extra resources. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, paper 5. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 16 says an electric kettle contains 4.25 times 10 to minus 4 cubic meters of water. The temperature of the water is 22 degrees Celsius. The kettle is switched on. The water takes 85 seconds to reach a temperature of 100 degrees Celsius. Show that the power of the kettle is about 1600 watts. And specific heat capacity of the water is given to us and density of water is also given to us. So how we can approach this problem? After reading this question, you need to understand is that this question is about specific heat capacity. So we will start with specific heat capacity. So simply we will say Q is equal to MC delta T. So this is the thermal energy supplied. But for this question, we need to calculate the power. So this is the energy. If we divide this one by delta T, so that becomes power. So if we divide this side by delta T, we also need to divide this side by delta T. This side also by delta T. Now we can rewrite this formula. So this is power. So this is MC delta T divided by time taken. So this is how we can calculate the power. So mass, but mass is not given to us. Mass is not given to us. So mass we need to understand. Mass is equal to density times volume. So we can plug in value of mass, means we can write down mass is equal to density times volume. So we can write down here. This is a beautiful way. This is how you need to approach in a systematic way. So this is delta T and this one is time. So now simply we need to plug in values. And if we plug in values, our answer will be about 1630 watts. So in this case, we no need to change the units because already temperature is given in degrees Celsius, but you need to understand the difference in temperature in degrees Celsius is equal to difference in temperature in Kelvin. So it means you can directly use temperature in degrees Celsius. And if you plug in values now, this will be the answer. Now let me show you the answer how I have solved. So if you plug in numbers, this is one way you can also answer this question. So in this case, first of all, I have calculated what is mass. So this one is the mass. Then we are using this formula. So I have calculated amount of thermal energy supplied. Then I divide it by time. So that is the power. But you can also simply use this one because this is important for your understanding. Part B says the water boils at 100 degrees Celsius. Calculate the time now taken for 75% of the water to boil away. Specific latent heat of vaporization of water is given to us. So the time taken we need to calculate. So again we can use the same approach. So if you read this question, you can see from here, this is about latent heat of vaporization. So simply we can say latent heat of vaporization, simply Q is equal to M times L. And in this case, 75% of water boils away. 75%. So it means this is 0.75 of water or 0.75 of the mass of water. So this is 0.75 M. M is the total mass of the water times L. So we can calculate Q. As for this one, we need to find out time, but P we have already calculated. So then we will be able to find time. We will go to that point later. Now simply you need to plug in values. So we have 0.75. Again, you can say rho times volume times L. And you can plug in, you will be able to get value of Q. And when we have value of Q, and this is the L actually, this is latent heat of vaporization. So this is LV, latent heat of vaporization. So this is latent heat of vaporization. Now simply we need to plug in and we will get value of Q. Now when we have value of Q, then we need to understand is that P is equal to Q over delta T. But we need to find out delta T, so this will be equal to Q divided by P, and the value of Q we have from here, and we will divide by value of P we have calculated in the last part, that was 1630, and we can find out value of time. So this is how you need to approach. Now let me show you the answer with numbers. So here I have done this one with numbers. So simply you can check here what we have done. First of all, we have calculated delta E. So this is value of the Q for 75%. So this factor is why? Because for 75%. So this is then how we have calculated time. Pretty straightforward question. So when you do question, try to understand the logic. That's the reason at the beginning I solve question without numbers, and then I use numbers. Before we go to next question, I want to explain you one very important point. So Q is equal to ml. Now can you tell me what m is representing here? M is not, if you simply say m is the mass of water, that is wrong. M is mass of water. You have to be very clear. Mass of water boiled away. Very important one. So this is the misconception many students they have, or this is not explained in this way in the class. So m here is not only mass of water, it's mass of water boiled away. Mean this amount of thermal energy caused this much mass of water to boil away. So that mass you have to use, not the mass of water. So this is what this one is representing. Mass of water boiled away. Mass of water boiled away. So this question can be asked you in a different way next time. So if your basic concept is not clear, you don't know what m is representing, of course you will struggle to answer the question. Question 17 says Makemake is a dwarf planet in the solar system. Makemake has a mass of this much and a radius of this one. Calculate the gravitational field strength at the surface of the Makemake. So simply in this case, let's try to understand what is given to us. So this is the planet, dwarf planet. The mass of this one is given to us. So in this case, let's say this is representing m, and the radius of this one is given to us. And we need to find out, so this one is the radius. We need to find out what is value of g at the surface, mean at this point. We need to find out what is value of g. So this is pretty straightforward one. So the g will be equal to g at surface. So we are talking about g at surface. So simply you can say g capital M divided by r square and plug in values and you can find the answer. Now let me show you this one with numbers. So if you have plug in values using this formula, your answer will be equal to 0.40 newtons per kg. Part B says the average distance of Makemake from the Sun is similar to average distance of the planet Pluto from the Sun. A website states the time taken by Makemake to complete one orbit of the Sun is 20% greater than the time taken by Pluto to complete one orbit of the Sun. Assess the accuracy of the website statement. So we have mass of the Sun that is given to us, orbit radius of Makemake is given, and orbit time of Pluto is given to us, and it is also given to us 1 year is equal to 3.15 times 10 to 7 seconds. So in this case, first thing you need to understand, what do you need to calculate? So we need to prove that time taken by Makemake. So we can say the time period of Makemake. So this is simply time of Makemake. This is 20% greater than time taken by Pluto. So if we divide the time taken by Makemake divided by time period of the Pluto, mean time taken to complete one cycle, this ratio should be equal to 1.20, means 20% more. If the time period is the same, will be 1. As the time period is 20% greater, so your answer should be 1.20. So to reach this conclusion, what we need is, this is already given to us. We have time of the Pluto, so we need to calculate time, orbital time of Makemake. So if we have, we can plug in here, we can find the answer. Now the question is that, how we can find out the orbital time of Makemake? So we need to go back to Newton's law of gravitation. So Newton's law of gravitation simply tells us, if we have this is our sun, so this is sun, let's say this is planet Makemake. So the gravitational force between them we can find, and that gravitational force is providing the centripetal force for Makemake. So this one will be Ft, gravitational force in this case is providing the centripetal force. It's not equal to centripetal force, because centripetal force is not a force by itself. Now simply we can write on here, so this is G capital M, means this is capital M is the mass of the sun, small m is mass of the small planet, divided by the orbital radius square, and this has to be equal to mr omega square. So we need to calculate time. So from here we can find out this m, we can cancel with this m, so we can find out what is omega square. Omega square will be equal to G capital M. If we divide both sides by r, we will get this one is r cube. So we can find out value of omega. So from here we can say omega, so divided by s. So here we can write down now, so this will be Gm divided by r cube. If we take square root of this one, we can find out value of omega. And when we have value of omega, then we can find out time period, because omega is equal to 2 pi over t. So from here we can find out value of t. So this is how you need to approach. In this case, this is in kg, so simply you can use, and radius is in meters, we can directly use. But you have to be clear about this one. This has to be the orbital radius, means the distance from the center of the sun to the center of the planet. Orbital radius must be given to you. If they simply give you the radius of the sun and radius of Makemake, and they give you the distance from the surface of this one to the surface of this one, then in this case the orbital radius will be equal to radius of the sun plus distance from surface to surface, means this distance d, plus radius of Makemake. So in this case, r here, so I'm saying this is orbital radius, distance from center to center, center of planet to center of sun. So this is, then you can find out t, and when you have value of t, so from here you can say t will be equal to 2 pi divided by omega, then you can plug in here and you can find. If the answer is 1.20, it means it's correct. If greater than, it means statement is not valid. If smaller, also statement is not valid. So this is how you need to approach. Now let me show you the answer with numbers, how you can do this one with numbers. So I hope this makes sense to you. So I will simply clean this one and show you with numbers now. So this is how we have done with numbers. So you can see, first of all, we have found omega, and then we have find out value of this omega, angular speed in this case. Then we have calculated time period. So here we have converted this one into years, and here we have divided. So we have found 1.24. So it means this is 24% more than time period of Pluto, orbital time of Pluto. So it means statement is not quite accurate. So this is how you need to approach. I hope this makes sense. And if you have any questions, please leave your questions in comments. I will try to answer as soon as possible. And if you are looking for extra resources, you can join Patreon On Patreon, you will see a lot of resources, exam revisions, and a lot of other resources. Question 18 says, in January 2023, the asteroid 2023 BU came close to the Earth. The closest distance of asteroid from the surface of the Earth was 3,590 kilometers. Calculate the force between the asteroid and the Earth at the closest distance. You may assume the asteroid as a sphere, is a sphere. Asteroid diameter is given to us, asteroid density is given to us, mass of Earth is given, radius of Earth is given. So we need to calculate force. So first of all, we will go to the main idea, how we can calculate force between Earth. So this is our planet, this is Earth. Let's say the mass of this one is capital M and this one is asteroid. Mass of this one is small m. So we need to calculate the force between these two. So gravitational force, so this is the force. So we need this distance. But for this question, what do we have? We have diameter of the asteroid, that is 5.65 meters. So it means we have to take the radius of this one. So this radius we need the radius of this one, and we need this distance. So that is the d. So d will be equal to, let's say radius of this one is capital R and the radius of this one is small r. So d will be equal to capital R plus, let's say this distance, we can say this one is R1, distance from the surface of Earth to the surface of this asteroid. So we can say that is R1 plus R, this one. So this is the distance from center to center. Now we need to use Newton's law of gravitation. So this is G capital M small m over d square. And so for this one value of G we have, this is a constant value of M capital M, mass of Earth is given to us. So we need to find the mass of the asteroid. So how we can find out mass of asteroid? This is a sphere, so this has to be equal to density times volume. And the density and the volume we can simply find out as it is a sphere, so 4 pi r cube. And now if we plug in values, we can find out the mass of asteroid. Then we can plug in values here, we can find the answer. So d is very important one. So d is the distance from the center of Earth to the center of asteroid. As in this case, the diameter of asteroid is very, very small. So we can ignore that one. The radius even will be smaller, that can be ignored. But the radius of Earth we cannot ignore, because radius of Earth is 6,380 kilometers. And this is 3,590 kilometers. This is the distance from the surface. So in this case, let me explain to you. This distance is given to you. This distance, this is given to you. From the surface of Earth, the closest distance value is given. And this distance also, we can take, this is taken from the center actually. So this distance is not from surface to surface. This distance is from actually the center. So it means these two, they are equal to this distance. So this is, so it means this is equal to 3,590 kilometers. So this is only the tricky part. You have to be clear which distance you have to use, and then simply plug in values and you can find the answer. Now let me show you the answer, how we can answer this question. So let me show you the full solution of this one. I hope this makes sense to you. Now please, simply you need to plug in values. As you can see here, first of all we have calculated the volume of asteroid. So this is volume. Then we have calculated the mass, and then we are simply using Newton's law of gravitation, mean the formula for gravitational force. And this one is the distance of closest approach. Let me explain you again. Distance of closest approach we are taking from the center of asteroid to the surface. So this distance is given. So is this one, and this one is the radius of Earth. So we have to take this r as well. So this one is r. So this is given in kilometers, so we have to convert it to meters. So this is the final answer. So the distance of closest approach, are the closest distances from the surface of Earth to the center of this one. They can also give you the distance from the surface of asteroid to the surface of Earth. Then you have to take the radius of asteroid as well. But in this case, radius is very small, so that can be negligible. Part B says calculate the change in gravitational potential energy of the asteroid if it had fallen to the surface of the Earth from a height of 3,590 kilometers. Assume that mass of the asteroid remains constant. So first of all, let's sketch and try to visualize. Let's say mass of Earth is capital M and this one is asteroid and its mass is small m. And let's say this point is 2 and this point is 1. So we can also take, this is at the surface, so we can take this distance, and let's say this distance is r1, and this distance means the distance from the center of asteroid to the center of Earth. Let's say this distance is r2. So we need to find the change in gravitational potential energy. So simply we can say delta GPE. This one has to be equal to m times change in potential. M is the mass of the asteroid. So we can take this as m. So the change in potential. So we can find the potential, final potential. So we can say here final potential minus initial potential, means potential at this point. So it means this is m. So the final potential, that will be G capital M divided by R1, but potential is negative, so negative sign we have to use, minus potential due to this one. So this is negative G capital M divided by R2. So this is, now if we little bit simplify this one, so in this case we can write on this one m. So here we will get, this is G capital M divided by R2, so this is positive. So here we have G capital M divided by R1. So this one is negative. Now if we take negative out, so we can take negative, this is G capital M small m, we can take out. If we take negative out, so this will be negative, this will be positive, so this will be Gm over R1 minus will be G capital, actually we have taken out already, so we can simply write down, this will be 1 over R1 minus 1 over R2. So now simply we need to plug in values. We have the formula, now simply plug in values and you can find the answer. So what is R1? Is the distance from the center to the surface. So this is the radius of Earth. And this is the distance, radius of the Earth plus this distance. It means here R2, let me write down. This will be radius of Earth plus this distance, 3,590 kilometers. Now simply plug in values and you can find the answer. So this is how you need to approach. So if it is moving from this point to this point, getting closer, it means the potential energy is decreasing. So the answer should be negative. And if it is moving away, potential energy should be increasing. So the change in potential energy has to be positive. So let me write down here. If it is approaching, mean getting closer, what will be the change in potential energy? Delta E. It has to be negative. So the answer must be negative. And if it is moving away, so we can say moving away means going away, change in potential energy has to be positive. So in this case, as it is approaching, so change in potential energy, because the potential energy is decreasing, so it has to be negative. It's same. For example, if this is the planet, this ball go away, what is the change in potential energy? positive. If it is falling, what is change in potential energy? Negative. So in this case it is falling. That's the point you need to understand. So approaching means falling, we can say in a simple language. It means moving away. You can say rising. So this is. Now simply we need to plug in values. Now let me show you the complete answer. And so here you can see we have already derived this formula. We have written in this form. Now simply we need to plug in values. So this is the radius of Earth, this is radius plus the distance, and this is our final answer. Answer in this case has to be negative because the change in potential energy is negative. If you simply remember this formula, so what is this one? This is the closest actually. Closest. This is closest distance. And this is further away. So we can say further away. So this formula you can also remember, otherwise you should be able to derive this one. Derivation is important because that will give you understanding. Part C says explain why the mass of the asteroid would not remain constant as the asteroid fell to the surface of the Earth. So in this case simply we can imagine this is our planet and there is an atmosphere, there are air particles all around this one. As asteroid is falling, this will interact with the air particles. So the kinetic energy will be converted into thermal energy. So due to the thermal energy, means due to heat, this will burn. So its mass will decrease. So these are the points you need to understand. So how we can write on the answer? So in the answer we can talk about these 2 points. We can say air resistance does work on the asteroid. When asteroid is falling, so there will be resistive force on the asteroid in this direction. So resistive force, and the work done by this resistive force will be negative. Asteroid is falling down and the force is in upward direction. So it will lose actually potential energy. As it will lose its potential energy, and that loss in potential energy will not be equal to gain in kinetic energy. That part of that one will be converted into thermal energy, and due to thermal energy this will heat up and it will burn, it will lose mass. So asteroid heats up and may burn due to atmosphere entry. So in this case asteroid is falling, even if we imagine it started from rest, so its potential energy has to be converted into kinetic energy. But due to air resistance, all the potential energy will not be converted into kinetic energy. Some of energy will be converted into thermal energy. So it will heat up. So it will lose mass due to burning. Question 19 says, in 2023, a small capsule of cesium-137 was lost when being transported from a mine in Western Australia. The activity of the cesium in the capsule was 19 gigabecquerel. Show that the decay constant of the cesium is about this one. And we need to be careful. This is in seconds. And half-life of cesium is given. This is in years. And 1 year is given to us is equal to these number of seconds. So we need to, half-life is given, we need to find out decay constant. So decay constant is equal to ln 2 divided by half-life. Ln 2 is a constant. So half-life simply we need to convert into years and we can find the answer. So in this case we can say this is ln 2, and how many years we have? 30.1. 1 year has this many seconds, so 3.15 times 10 to 7. Now if we solve this one, we will get the value of lambda, that will be in per second. So this is how you need to answer. Now let me show you the full answer, and also this answer is written a little bit in detail. So you see, first of all we have used this formula. So let me clear this first. So this is the formula first of all you need. Then you have to convert time into years, then use the formula, and this one is final answer. For the second part, we need to calculate the mass of cesium in the capsule. So how we can calculate mass of the cesium? Density, volume, those informations are not given to us. So you have to little bit think about this one, how you can calculate mass. So in order to calculate mass, so let's say this is capital M. If we can find out total number of nuclei and we have mass of one single nucleus, we can multiply and we can find the total mass. So we can say, if we can find out total number of nuclei of cesium and we have mass of one nucleus, so we can find out total mass. And mass of one nucleus we can find out because this is cesium 137. So we can write down this is N. Mass of one nucleus is equal to the number of nucleons multiplied by mass of one nucleon. And mass of one nucleon means mass of one proton or neutron is 1.66 times 10 to minus 27 kgs. So this is the main idea you need to approach. So this is how we can figure out. Now we need to find out value of N. How we can find value of N and which formula we have in nuclear physics which relate decay constant N and activity. So you need to little bit recall. So we have formula A is equal to lambda times N. We have initial activity, we have calculated lambda, so we can find out N. So it means N will be equal to the initial activity divided by decay constant. So if we plug in, we can find out. Initial activity was 19 gigabecquerel, 10 to 9. And value of lambda we have just found in the last part. So if we plug in values, so we can find N, then we can plug N here and we can find out the mass. So this is how you need to approach. Now let's go through the complete solution. So this is the main idea. This is what you have to develop in your head, how to approach. Then you can plug in numbers, you can find the answer. My main purpose of this solution is to help you to understand how to answer the question, not every time you stuck with new question. So this is first how you need to organize your thoughts. Now let's go through the complete solution. So here you can look at complete solution. So you can see I have written first of all this formula. Then I have calculated value of N using this formula because initial activity we have, decay constant we have calculated in the last part, and mass of one cesium nucleus is this one. This is mass of one nucleon, and then we multiply total number of nucleons. So these are total number of nuclei of cesium in the sample, and this is our final answer. For the third part, we need to calculate the activity of the cesium in the capsule after 2 years. Very straightforward question. We have initial activity. So we have initial activity. Now we need to find out after a certain period of time. So A as a function of time is equal to initial activity times e to the power of decay constant times time. Time passed. Time passed between these two means when this activity decreases to this one, how much time has passed, that time is here. So this is activity, remaining activity after time t, and this is the time taken from initial activity to decrease to this value. Now we have all the values, simply you need to plug in and you can find the final answer. But you have to be careful. This time you have to convert into seconds. That's the point simply you need to do. Now let's go through the answer. Now nothing else to discuss here. So the main concept I have already explained. Now you see what we have done here. We have simply plugged in values. So t we have converted into seconds. Then we have simply used this formula and this is our final answer. Initial activity was 19 gigabecquerel. Now we have 18.1. Part B says the capsule was found after 14 days. Calculate the total energy in joules released from the capsule in 14 days. Activity of cesium capsule is given to us. Energy released in each decay of cesium is 1.17 mega electron volts. 1 day is equal to 86,400 seconds. So when you read the question, how we can answer? So what do we need to calculate in this case? We need to calculate total energy released. Total energy released, and answer should be in joules. Total energy released. So if we can find out number of decays in 14 days, so we can multiply with energy release in one decay. So what we need to find out? We need to find out n, number of decays in 14 days, and then we multiply with energy release in one decay. So we can say energy released per decay means energy released in one decay. Then we can find out the total energy release. So this is the main physics. So how we can calculate number of decays? So look at this one. Activity is given to us. So what is activity? Activity is telling us number of decays per second. Number of decays per second. So this is given in becquerel, mean number of decays per second. So this is given to us. So we have how many decays are happening in 1 second, and if we have the total time, we can find out total number of decays. So how we can find total number of decays? So we will be writing here total number of decays. How we can find out? In 1 second, how many decays we have? 19 gigabecquerel. 19 giga, 19 times 10 to 9 number of decays we have in 1 second. And how about the total number of seconds? Total number of seconds will be 14 times number of seconds in 1 day, that is 86,400. That is given to us. So by solving this one, we can find out total number of decays. So now we have total number of decays, we have energy released per decay, we can calculate energy released in 14 days. Then that answer we can convert into joules. So this is how you need to answer. I hope this makes sense to you. Now let me show you the full answer. So here is the answer. In the answer, you can see, first of all, we have calculated number of decays, and this is the energy released in one decay. We have converted into joules. Now simply we multiply number of decays with energy released in one decay, and this energy is in joules. So our final answer is also in joules. So this is how you need to answer. And today's lesson I will stop here, and remaining 2 questions I will try to upload as soon as possible. And if you have any questions or if you have any doubts, please leave your questions and your doubts in comments, and I will try to answer as soon as possible. And also, if these videos are helping you, please like and subscribe, and also leave some comments, and also share with your friends. And if you're looking for more resources, you can join Patreon. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, paper 5. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 20 says, a 150 grams mass was hung from a spring as shown in the figure. The spring extended by 7.5 centimeters. The mass was displaced vertically 3.0 centimeters from its equilibrium position, then released. The mass oscillated vertically. Explain why the motion of the mass was simple harmonic motion. For simple harmonic motion, there are two conditions you need to understand. Spring force is directly proportional to the displacement. When the displacement is maximum, spring force will be maximum. When the displacement is minimum, spring force will be minimum. And direction of force and displacement, they are in opposite directions. So what exactly I'm saying is that for SHM, you need to understand these conditions. Acceleration is directly proportional to displacement, but here we have also negative sign. It means that acceleration and displacement are directly proportional, but they are in opposite directions. When acceleration is positive, displacement is negative. When displacement is negative, acceleration is positive. And acceleration and force, they are always in same direction. So we can say force and displacement, they are directly proportional, but they are in opposite directions. And this is true for this system as well. So that's the reason the motion of this one is simple harmonic motion. So these points you have to write down in the answer. And this question has 2 marks. So 2 points you can write down. So the first point you can say force is directly proportional to displacement, as force is depending on displacement. Force and displacement, they are in opposite directions. Now let me show you the answer, how you can write down your answer. Restoring force, you can say point 1 proportional to displacement. Second, you can say direction of the force. Force always acts towards equilibrium. It also means that force is in opposite direction of displacement. So when the mass is here, for example, mass is here, so the displacement in this case, we can take displacement is negative because this is downwards, we are taking up is positive. But force, spring force on this one will be in upward direction. The mass is here at this point. Force will be downward, means force is always towards equilibrium. These 2 points you have to mention in the answer. So if you have written, you will get 2 marks. Part B says calculate the maximum velocity of the oscillating mass. But for this one, there are few points you need to understand how to answer this question, and also those are very important concepts. So first of all, we need to calculate Vmax, and Vmax simply is equal to amplitude, means the maximum displacement, times angular frequency, omega. But how we can find out value of A? Value of A is already actually given to us. So let's try to understand this one step by step. So first of all, in the question it was given to us, we have the spring, and then we attach mass with this spring. So when we attach mass, this spring extended by, so this extension is given in the last part. This is equal to 7.5 centimeters. So at this point, mg is acting down, mg is down, and spring is in equilibrium at this point. So the spring force is equal to mg. But then we extend this one further down. So let me draw here. So we extend this one further down. It is here. So from here, actually, this one we can say this displacement is 3.0 centimeters, and this is the amplitude. Now with this one it will start oscillating. So this is 3.0 centimeters down, then it will go up by 3.0 centimeters. So it will be oscillating with amplitude of 3.0 centimeters. So this is the main story. These are the concepts you need to understand. Now how we can find out value of K? So to find value of K when it is in equilibrium at this point, so we can simply say mg, this one has to be equal to the spring force kx. So we can say K from here will be equal to mg divided by x. So value of mg we will plug in, value of x is this one, and we can find out value of K. And when we have value of k, then we need to find out omega. So you can find omega by two different ways. So first thing you need to understand, time period of spring mass system is equal to 2 pi m over k. If you compare, t is also equal to 2 pi over omega. So if you compare these two, we will get omega is equal to k over m. Q over m. So this is the omega. So we can get value of k from here, value of m already we have, so we can find omega. Or simply we can say omega square will be equal to k over m. So if we have value of k from here, means we will calculate from here. Mass attached with this spring is already given to us. That was equal to 150 grams, and we can find out value of omega. Then we can plug in here and we can find the V max. Or you can directly use this one. You can use this, and you can also try to find out value of omega from here. You can also try to find, but this is a smart way to answer. So omega you can find out from here. Omega is equal to k over m. So if you use this one, you will find time period first of all. If you use this formula, then you will find frequency. Then frequency you will say is equal to 2 pi f. Omega is equal to 2 pi f. So from f you will be able to find omega. So that will be a little bit long. If you have this understanding, you can plug in values, you can find the answer. I hope this gives you the main idea how to answer the question. Now let's go through the solution I have written. So we can go through the solution how to find the answer. So simply as I explained you, first of all we have found the value of k. Then we have find value of omega. I have explained why omega is equal to square root of k over m. So you will get the value of omega. Then V max is equal to omega times a, and this is our final answer up to 2SF. This is the final answer. So this is how you need to approach. Part C says explain why the maximum velocity of the oscillating mass decreased over time. Velocity will decrease. There are two main reasons. One is due to air resistance. So due to air resistance, the system will be losing energy. Means the mechanical energy of the system will be converted into thermal energy. And also due to internal friction, mechanical energy will be converted into thermal energy. So the system will be losing mechanical energy. It means kinetic energy will be decreasing. So the maximum velocity will be decreasing. So these are the points you need to understand. Now let me show you the answer. So in the answer, you can write down these points. So first point, you can say the system loses energy due to air resistance and internal friction. As energy is dissipated, so amplitude decreases, and of course velocity will also decrease. So this is how you can answer. Question 21 says during their life cycle, stars go through a number of stages. Betelgeuse is a red giant star with a luminosity of 4.49 times 10 to 31 watts. The peak intensity of radiation from Betelgeuse occurs at a wavelength of 850 nanometers. A website claims that the radius of Betelgeuse is 1000 times the radius of the Sun. Assess the accuracy of this claim. So surface temperature of the Sun is given to us, luminosity of the Sun is also given to us. So for this question we have to compare the radius, and for that one we need Stephen-Boltzmann law. Means the luminosity, this is equal to sigma A T to the power of 4. So radius is involved, so you have to use Stephen-Boltzmann law. And here in this case, the area of the star, surface area of the star, this is 4 pi r square times t to the power of 4. So r is the radius of the star. Now for Betelgeuse, we don't have its radius, we don't have its temperature. So first of all we need to calculate its temperature because we have the wavelength of peak intensity. So we can use Wien's displacement law. So first of all, we can use Wien's displacement law. We can say lambda max times t, this is equal to constant. So this is equal to constant, and the value of this one is about 2.8 times 10 to minus 3 meter Kelvin. So this is the value of the constant, approximate. Now from here we can find out temperature in Kelvin. So we can find out temperature in Kelvin. So if we have this temperature, so we can use here. But if you look at this formula, in this formula you can see luminosity over R square divided by T to the power of 4. This is equal to sigma times 4 pi, and this is constant. This is constant for any star. So this is constant for Betelgeuse. It is also constant for Sun. So simply in this case we can say L of Sun divided by the R for the Sun. So I'll be using letter S, and surface temperature of the Sun, this has to be equal to luminosity of Betelgeuse. I'll be using P sub P, and this is radius of Betelgeuse square, and surface temperature of Betelgeuse T to the power of 4. So we need to find out the ratio between RB and RS. So we can write down from here that luminosity of the Sun times RB square times TB to the power of 4. This has to be equal to LB RS square and TS to the power of 4. So we can say from here RB over RS square. So we have the square here. This has to be equal to LB TS to the power of 4 divided by, this has to be luminosity of the Sun times T temperature, surface temperature of Betelgeuse to the power of 4. So from here we can find out. Now if we take square root on both sides, square root on both sides, so simply we can take square root of this one and we can find the ratio. If this ratio is close to 1000, it means statement is valid. If not, statement is not valid. Now simply we need to plug in values. So the luminosity of Betelgeuse, we have, this is luminosity. We have surface temperature, we have found surface temperature of the Sun. So this is surface temperature of the Sun. So we can plug in here. Luminosity of the Sun, we have, this is, we can plug in here. And temperature of Betelgeuse we have found from here. Now simply plug in and find the answer. So this is how you need to approach the problem. I hope this makes sense to you. Now let me show you the answer with numbers, how you need to calculate. So here this is how you need to calculate if you plug in numbers. So this is how you will get the final answer. So we have calculated, first of all, this is Wien's displacement law we are using. We have got surface temperature of Betelgeuse, then we are using Stephen-Boltzmann law. So this is Stephen-Boltzmann law as we have discussed before. Then we are using the ratio. So in this case answer is about 990. As this value is close to 1000, so it means the statement is valid. So this is how we can. And second part says the HR diagram shows the positions of some main sequence stars. Add the approximate position of the Sun and Betelgeuse to the diagram. Mark the positions with labeled crosses. So in this case, first thing we need to understand is that the luminosity of the Sun as a reference we take is equal to 1. Equal to 1. So it means Sun luminosity here. So this is luminosity of the Sun. We take this one as a reference. This is equal to 1. So it means Sun must be located here. So Sun can be in this region. So Sun can be located here. So this is, we can say this one is Sun. So Sun can be located here. And for the Betelgeuse, the luminosity of the Betelgeuse we have this one. And luminosity of the Sun is about equal to 3.8 times 10 to 26. So this is 31. So it's about 10 to 5 times greater than intensity of the sun. And the surface temperature of Betelgeuse we have found that was about 3400 Kelvin. So luminosity should be about 10 to 4. So it means it can be located here, 10 to 4, more than 10 to 4. So it can be here. It can be here in this region. And the temperature, this is 2500, so temperature is 3400. So Betelgeuse can be located in this region. So this one is Betelgeuse, so we have to write down the name of the Betelgeuse. So I'm just writing B here. This is for Betelgeuse. So this is how you can answer. So and this is a red giant, so it has to be away from the main sequence. You can also compare the luminosity, as this is luminosity of Betelgeuse, this is luminosity of the sun, and luminosity of the sun on HR diagram we take 1 as a reference, and then we can compare the luminosity of other stars with the luminosity of sun. And surface temperature we have also calculated, so you can see from here this is 2500, so temperature has to be greater, so it has to be on the left side. Now let's go to next part. Question is asking us, state what is meant by a main sequence star. So main sequence stars means when the star is at the main sequence, star is stable, and when the stars are stable they are fusing hydrogen into helium. So these points you have to write down. If you write down, you will get 1 mark. So now let me show you the answer. So this is for our previous question, and this is for the next one. So this is, so you can see the exact positions on this one, and this answer you can see now. Main sequence, you can say fusing hydrogen into helium, maintaining a stable equilibrium between gravitational attraction means contraction and thermal expansion. And this is the longest stage in star's life cycle. So these points you need to understand about main sequence star. Part B says the final stage of evolution for a massive star may be a rotating neutron star. One neutron star rotates with a period of 33.5 milliseconds. As the star rotates, one side of the star moves towards Earth while the other side of the star moves away from Earth. This causes a range of wavelengths to be received by an observer on our planet. Ultraviolet radiation of wavelengths 91.2 nanometer is emitted by the star. This radiation is emitted by the star, but for the observer, the observed wavelength, that will be different. Calculate the maximum and minimum wavelengths observed. One side of the star is approaching, so maximum wavelength, the other is moving away, so they will be, star is approaching, so that wavelength will be small, star is moving away, that wavelength will be longer. So we need to find out those two values. Diameter of the star is given to us, so we need to find out lambda max. So lambda max will be equal to the lambda emitted. So let's try to understand the main concept. Plus redshift means the Doppler shift. So this one is Doppler shift, delta lambda. And how about lambda minimum? Lambda minimum will be equal to the lambda emitted minus delta lambda. So this is the blue shift and this is red shift. So how we can find out delta lambda? Because lambda emitted we have, so how we can find out delta lambda? To find delta lambda, we need to understand Doppler shift equation. That is delta lambda over lambda is equal to V over C, and this is lambda emitted. So lambda emitted we have C, this is a constant, so if we have V, actually we can find out delta lambda. So how we can find the V? So this one is the star, so this is star, and this star has certain angular velocity, and the velocity, tangential velocity, is maximum at this point when it is moving towards or moving away. So the v at this point is maximum. So we need to find out this value of v, and that will be equal to r times omega. We have diameter of the star, so we can find the radius from here. We can find value of r. So we need to find omega now. How we can find omega? Omega will be equal to 2 pi divided by the time period of the star. So here we have time period of the star. So we can find value of v, and we can plug in value of v here, and then we can find out delta lambda, and then we can find lambda max, we can find lambda minimum. So this is how you need to approach. I hope this makes sense to you now. Now let me show you the answer with numbers. Let's go to the solution. So always organize your thoughts first of all. What is the main thing you need to calculate? Start from that, then go backward. What is given to you and what you need. Then you need to figure out how you can find the value of the unknown quantity. So if you look at this answer now, you can see I have written this one. So first of all, what I have done is I have calculated omega. So this is value of omega, and then we have found V max, then we have found delta lambda by lambda, and then from here we have delta lambda. So this is Doppler shift. So this is value of Doppler shift, means the change in the wavelength we have calculated. So then we have added, so this is red shift and this is blue shift, and this is the answer. So this is how you can approach this question. I hope this makes sense to you. This is very nice question because it involves more than one steps. So multi-step questions are very important to practice. If you want to improve your understanding of physics, so do multi-step questions. One-step questions are easy questions. Multi-step questions help you to organize your thoughts, and they help you to develop your understanding. And that's all for this video. We have done this whole paper. So if you have any questions or any doubts, please leave your questions in comments and I will try to answer as soon as possible. And if these videos are helping you to improve your understanding of physics, please like and subscribe, and also share with your friends. And if you're looking for extra resources, you can also join Patreon. On Patreon, you will see a lot of resources. See you in next video. And all the best for your coming exam.